Welcome. This will be the first video in a series on writing formulas. What we're going to do right now is predict the charge of an element using the periodic table. Now, one thing that we should keep in mind is that typically nonmetals will gain electrons forming negative charges, whereas metals will lose electrons forming positive charges. What we're going to do is we're going to figure out why nonmetals gain electrons and why metals lose electrons, and how many they typically gain and lose. For that, what we need is the periodic table. Now, typically, what this little stair step does on the periodic table is it divides the metals from the nonmetals, where the metals are over here on the left-hand side of the periodic table, and the nonmetals are over here on the right-hand side of the periodic table. Now, one thing that all metals and nonmetals are going to have in common is they want to achieve noble gas electron configuration. So they want to have full outer shells. That's basically what that's going to indicate. That's what that's going to tell you. Now, how would they go about doing such a thing? Well, first of all, chlorine, for example, has 17 total electrons. It has an atomic number of 17. Argon has 18. So chlorine would like to gain one more electron, forming a -1 charge. It would gain one electron to be like argon, having 18. Bromine has 35 electrons typically, but it wants to gain one electron to be like krypton, having 36 electrons. Bromine and chlorine both want to gain one electron. Let's check out fluorine. Fluorine has 9 electrons typically, whereas neon has 10 electrons typically. If it gained one electron, it would form a -1 charge, and it would have neon's noble gas electron configuration. Every element in this very first column on the periodic table, or in the very second to last column on the periodic table, will form a -1 charge, typically. What we're going to go over here is general rules, not hard and fast all the time. But almost always, these guys form -1 charges. Similarly, 8 versus 10, 16 versus 18, 34 versus 36. What do all these have in common? They're 2 away from being like a noble gas. They have to gain 2 electrons. Remember, electrons are negatively charged. Nitrogen and phosphorus, 17 and 15. 7 plus 3 is 10. 15 plus 3 is 18. These guys typically form a -3 charge. All right. When you look at aluminum, let's look at aluminum real quick. 13 electrons. Argon has 18. That would have to gain 5 electrons. But if we looked at the noble gas before aluminum, 13 minus 3 gives you 10. If you lose 3 electrons, you'll have 3 less electrons than you do protons, giving you a charge imbalance of +3, because you have 3 extra protons. You lost electrons, forming that +3 charge. Next, let's swing all the way over here, all right, and let's look at group 1A and 2A. Group 1A, hydrogen has 1 electron. Lithium has 3, sodium 11, potassium 19, rubidium 37. 3 minus 1 gives you 2. 11 minus 1 gives you 10. 19 for potassium. 19 minus 1 gives you 18. 37 minus 1 gives you 36. All of these guys will minus 1 electron. They'll lose 1 electron, forming a +1 charge. All of these guys will lose 2 electrons, forming a +2 charge. Why don't you check that out? The last thing that we'll have to discuss, and we'll discuss this in the very next video, is what to do about these transition elements. We don't know what the charge is for here, these guys in the middle of the periodic table, but we do know +1, +2, +3, -3, -2, -1. Those are the charges of these group A elements. Thank you. remember what we did here today. Nonmetals, the ones on the right-hand side, typically will gain electrons forming negative charges, depending on how far away they are from being like a noble gas. And metals will typically lose electrons. These are on the left-hand side of the periodic table, forming positive charges. Hope you follow that, and good luck in constructing formulas in the future.